It is January 19, 2006, when NASA's New Horizons spacecraft leaves our blue home planet for the realms of the remote Pluto system. After a 9-year flight, the unmanned spacecraft reached its intended destination, allowing it to give us a detailed look at previously unexplored worlds for the first time. The former planet, added to the star charts on February 18, 1930, Pluto was a permanent member of our planetary system until August 24, 2006. However, as more and more Pluto-like objects were detected in the Kuiper belt, the International Astronomical Union decided to reconsider the official planet definition. So it came to be that Pluto was classified in the newly classified ranks of dwarf planets. With an equatorial diameter of 1,475 miles, the celestial body is significantly smaller than Earth's constant companion. In this category, our Moon measures 2,159 miles. Since Pluto moves on a very eccentric orbit on its journey around the Sun, the distances between the dwarf planet and our host star also vary considerably. The largest distance between the two celestial bodies is 4.6 billion kilometers, the smallest distance is about 3 billion miles. As a result of this large spatial distance, Pluto needs about 248 years to completely orbit the Sun. If one were to look up at the sky from Pluto, the Sun would appear there merely as a strikingly bright star and not as a large dazzling silhouette as is the case on Earth. The enormous distance to the Sun is also responsible for the bitterly cold temperatures on the surface of the celestial body. On average, the thermometer here drops to -44 degrees Fahrenheit. To describe a rotation around its own axis, Pluto again needs about 6.4 days. Just like Uranus, the dwarf planet has an unusually inclined axis of rotation. While until today researchers puzzle over why Uranus lies practically on its side, the background in the case of Pluto is obvious. The intrinsic rotation of the celestial body is bound to the orbital motion of its moon Charon by tidal forces. Especially exciting is the fact that the two celestial bodies have a double-bound rotation. This means that they always present one and the same side to each other. With a diameter of 1,746 miles, the satellite is half the size of the dwarf planet. Because of these size relations, it's still being discussed whether it would not be more meaningful to speak, in the case of Pluto and Charon, as a double planet. Considering the material composition, it's considered as probable that Pluto consists of 70% rock and 30% ice. In detail, the celestial body has a massive rocky core that makes up almost 2/3 of its total diameter. The gigantic stony heart is surrounded by 2 layers of water and nitrogen ice. In this transitional region between mantle and core, melting processes may have formed a huge subsurface ocean possibly existing to this day. Unique phenomena. On July 14, 2015, it finally happened. The New Horizons spacecraft completed its Pluto passage, passing the dwarf planet at a speed of 9 meters per second. Meanwhile, the spacecraft approached within 7,700 miles of the dwarf planet. The mission was able to produce global maps of Pluto and Charon, and the high-resolution images present the celestial bodies to us in unprecedented detail. A revisiting of the New Horizons images now suggests that the dwarf planet harbors a unique phenomenon, namely, a previously unknown form of ice volcanism. The existence of this so-called cryovolcanism has been known for some time. In fact, we also find this exciting natural spectacle on our blue home planet. The volcanic formations do not spit out boiling hot lava or magma, but a bone-chillingly cold ice mixture. On Earth, we find such objects in northern Siberia, Canada, and Alaska, for example. We also know about extraterrestrial cryovolcanism. Ice volcanoes have been detected on Saturn's moons Titan and Enceladus as well as Pluto's companion Charon. However, the findings obtained by the researchers now suggest that Pluto's ice volcanoes clearly dwarf all comparable formations. In the course of their evaluation, the experts focused on the dome-shaped structures on Pluto's surface, which had not been studied in detail before. Based on the shadows cast, the experts were able to identify which valleys and elevations are hidden in the region under investigation. The exciting result, the 4-mile-high Pickard Mons and the 3-mile-high Wright Mons are most likely the result of cryovolcanism. Novel ice volcanism. Prior to the work, it was speculated that the giant mountains might even be ice volcanoes themselves. However, a detailed analysis of the surface structures quickly showed that Pickard and Wright Mons deviate significantly from the well-known scheme. Accordingly, the formations have strikingly large and unusually shaped openings, which do not correspond in their nature to later collapsed craters. In addition, no clear traces of directed rivers could be found, and there was no trace of material that had flowed out. Instead, the area is adorned by lumpy basement elevations, hundreds of feet high and up to 12 miles wide. This circumstance also appears unusual for conventional cryovolcanism. Thus, the Picard and Right Mons environments differ not only from Pluto's other landforms but also from most other known surfaces in the Solar System. Moreover, since the region has hardly any impact craters, it's reasonable to conclude that it must be geologically quite young terrain. Accordingly, the landscape transformation took place only long after the actual birth of the dwarf planet. This assumption is also supported by the collected spectral data. Thus, the basic material of the massif is composed of frozen water ice, which is as hard as stone. Above this, in turn, is a thin mantle of lighter ice forms such as nitrogen ice and frozen methane. Organic deposits have also been detected in this natural coating. Since the thickness and the composition of the shells show large deviations, the assumption suggests itself that these were formed by no means in the same breath but at different times. In this regard, experts now believe that the gigantic mountains and the surrounding terrain were created by a previously unknown form of cryovolcanism. In detail, viscous water ice penetrated from several exit points from the underground to the surface. There, this mobile mass accumulated into dome-shaped elevations, with some of these outgrowths merging over time to form the landscape visible today. A profound theory. With this exciting theory, the unusual appearance of the terrain could be fully explained. And the background of the enormous mountains, where today the mighty Picard and Right Mons rise, there were once several closely placed exit gaps. From there, new masses of water ice constantly reached the surface, with the newly emerging material pressing the already existing material higher and higher. If the suspected scenario is confirmed in future studies, Pluto would host a hitherto unique form of cryovolcanism. In the same breath, however, confirmation of the thesis would also,